Hello everyone, the question says that a spring whose in-stressed length is L has a force constant K. The spring is cut into two pieces of unstressed length L1 and L2, and where L1 is an L2, N is an integer, the ratio of K1 and K2 of the corresponding force constant K1 and K2 will be. Now first we will write, we know force constant, that is K1 equals to C upon L1, where C is constant. Now similarly for K2, K2 will be equals to C upon L2. Now ratio of K1 and K2 will become equals to C upon L1 and C upon L2. Now it is given L1 equals to L C L2. So it is given L1 equals to C L2. Now on substitution of the value, so we can write this value as NL2 because we have given L1 equals to NL2. So now put this value, so we get C will cancel out. So we get L2 divided upon N L2. L2 will also cancel out. Hence ratio of spring constant K1 K2 will be 1 upon N. Hence this is our right answer, that is option C. Hence option C is right. I hope you understood this explanation. Thank you.
The given question is, a small block is connected to an end of a massless spring of unstretched length 4.9 meters. Means we have a block here which is connected to a spring whose original or unstretched length is 4.9 meters. The other end of the spring is fixed. The system lies on a horizontal frictionless surface. The block is stretched by 0.2 meters and released from rest at t equals to 0. It then executes simple harmonic motion with angular frequency omega given as pi by 3 radians per second. Simultaneously at t equals to 0, a small pebble is projected with speed v from point P at an angle of 45 degrees as shown in the figure. So basically this block has been stretched by 0.2 meters from its mean position, and then it is being released and it is performing an SHM with omega pi by 3. And at the same time t equals to 0, a small pebble at P has been projected with a speed v at an angle of 45 degrees. Now point P is horizontal distance of 10 meter from O. If the pebble hits the block at t equals to 1 second, the value of v is, and we have to find the value of v, and g is given to be 10 meter per second square. And these are the options: root 50, under root 51, under root 52, and under root 53 meter per second. So basically we are given, see, if this is the mean position of the block, so we have this distance as 4.9 meters, okay, at t equals to 0. And if this distance is 4.9, then this distance will become 5.1 meter, right? The distance of the pebble. Now at t equals to 0, this object has been stretched by 0.2 meters. So let's say this block has been stretched up to somewhat here, okay, by 0.2 meters. So this distance will total will become up till this length will become 5.1 meter, right? So this distance will become 5.1 meter, and if this is 5.1, then this distance will become 4.9 meters. Okay. So now at this point, at this t equals to 0, this block or this spring has been released such that it will perform a SHM and it will tend to move in this direction, right? And a pebble is being projected from point P such that after at t equals to 1 second, they both are colliding, okay, or we can say the pebble is hitting the block. So let's first of all find the distance in 1 second the block has covered, okay. So we have, see, now the block has been taken to the extreme position and then it is being released at t equals to 0. So the SHM equation of the block would be given as x equals to a cos omega t, right? A cos omega t. So here a will be 0.2 meters because it is only stretched till 0.2 meters, okay. This is the amplitude, it can maximum go by 0.2 meters. And cos, we have omega given as pi by 3 radians, pi by 3 t. So this is the equation of SHM. Now at 1 second the block will be at 0.2 into cos pi by 3 into t is 1, and we have 0.2 into cos pi by 3 is 1 by 2, so this will become 0.1, and we will have x equals to 0.1 meters. Okay, so let me draw this clearly and explain. See here, see now at t equals to 1 second, this was the mean position initially, and block has started from this position, and this distance was 0.2 meters. And now see in 1 second, the block has covered 0.1 meters, means the block is somewhat here. Okay, and this distance originally was 4.9 meters, and now this 0.1 meter. So the block is at this instant, at the instant of hitting, is at 5 meters, right, from position O. And if this is at 5, then this range of the pebble would also be 5, right? This is the complete range of the pebble. So now we have the formula for horizontal range will be given as r equals to u square sine 2 theta over g, right, for a projectile motion. So here we have the range of the pebble is 5 meters. So this is 5. U see, it is u is the initial velocity which is given as v in the question. So this will be v square into sine 2 into theta. Theta of projection is 45 degrees. So this is 45 degrees divided by g. We have to take 10. Okay, so from here we will get 50 equals to v square, and sine, this is sine 90 is 1. So by taking square root both the sides, we will get v equals to under the root 50 meter per second. So this is the required initial velocity, and from the given options A, B, C and D, option A is the correct answer. Thank you.
In this question, a wooden block perform SHM on a frictionless surface, okay, with frequency mu naught. The block carries a charge plus Q on its surface. If now uniform electric field E is switched on as shown in the figure, okay, then the SHM of the block will be, okay. तो देखिए यहाँ पे फ्रीक्वेंसी का एक्सप्रेशन क्या होता है, फ्रीक्वेंसी जो होता है टाइम पीरियड का इन्वर्स होता है, तो टाइम पीरियड क्या होता है, टी इज इक्वल टू ये हो जाएगा 2 पाई अंडर रूट होता है, क्या होगा यहाँ पे, ये हो जाएगा हमारा एम बाई के, ठीक है। अब हमें फ्रीक्वेंसी निकालना है, फ्रीक्वेंसी को ये किससे डिनोट कर रहा है, म्यू नॉट से, तो म्यू नॉट क्या होगा, म्यू नॉट जो होगा वो हो जाएगा 1/2 पाई अंडर रूट के बाई एम, ठीक है। तो देखिए अगर हम इलेक्ट्रिक फील्ड का स्विच ऑन करते हैं तो हमारा जो के है और एम है वो इलेक्ट्रिक फील्ड से तो अफेक्टेड है नहीं, ठीक है। तो फ्रीक्वेंसी जो होगा वो रिमेन सेम होगा, ठीक है। बट देखिए इलेक्ट्रिक फील्ड का डायरेक्शन इस डायरेक्शन में है और क्यू चार्ज है, तो इस पर फोर्स क्या लगेगा, जो फोर्स लगेगा वो लगेगा क्यू ई, ओके, इस डायरेक्शन में। लेकिन जब स्प्रिंग है कंप्रेस होगा तो ये एक और फोर्स लगाएगा अपोजिट डायरेक्शन में, न्यूटन्स लॉ अगर फॉलो करता है तो क्या लगाएगा, ये अपोजिट डायरेक्शन में फोर्स लगाएगा, ओके। तो ये फोर्स क्या होगा, ये फोर्स जो होगा वो के एक्स के इक्वल होगा, ठीक है। तो एक्स यहाँ से जब एफ ई मतलब एफ ई जो इलेक्ट्रोस्टैटिक्स फोर्स है इज इक्वल टू एफ हो जाएगा, ओके। तो एफ ई क्या है, क्यू ई इज इक्वल टू के एक्स, तो यहाँ से एक्स क्या हो जाएगा, एक्स हो जाएगा क्यू ई बाई के हो जाएगा। तो जो शिफ्ट मतलब ये मीन पोजीशन है, यहाँ से कुछ एक्स इस डायरेक्शन में ये ब्लॉक शिफ्ट हो जाएगा, ठीक ना, शिफ्ट मतलब ब्लॉक का मीन पोजीशन शिफ्ट हो जाएगा, ओके। तो ये जो ऑप्शन होगा ये ऑप्शन ए हमारा करेक्ट होगा, सेम फ्रीक्वेंसी एंड विथ शिफ्टेड मीन पोजीशन, ओके। मीन पोजीशन कितना शिफ्ट होगा, क्यू ई बाई के जो होगा शिफ्ट हो जाएगा इस इस साइड में, मतलब कि राइट साइड में QE/K शिफ्ट हो जाएगा, मीन पोजीशन, और फ्रीक्वेंसी सेम रहेगा. ओके.
Hello everyone, so our question is, a uniform rod of length L and mass M is pivoted at the center. Its two ends are attached to the two end springs of equal spring constant K, and the springs are fixed to rigid support as shown in the figure. The rod is free to oscillate in the horizontal plane. The rod is gently pushed through a small angle of theta in one direction and released. The frequency of the oscillation is. Okay, so in the given question we have been given that a uniform rod having a length of L. So this rod is having a length of L. Okay, now which is pivoted at the center. So this distance will be L/2 and this will be L/2. Now the two ends of the rod are connected by two springs having a spring constant of K. Okay, now if we displace the rod by an angle of theta, then we have to find what will be the frequency of the oscillation. Okay, so let us suppose that we have displaced the rod by an angle of theta. Okay, so the extension in the first spring will be equals to the extension in the second spring. Okay, and this distance or the extension will be equals to L/2 into theta. So let us suppose this is theta, correct? So the extension in both the spring will be L/2 theta. So the force acting on the first spring will be in this direction, let us suppose as F, and similarly in the second spring it will be in this direction. Let us suppose the direction is in the right hand side. Okay, so what we can say that the force acting on each end of the rod will be equals to F is equals to Kx, correct? So force acting on each end of the rod will be equals to F is equals to Kx, and x is what? L/2 theta, correct? So it will be K into L/2 times theta, correct? Now so the restoring torque will be equals to restoring torque on the rod will be equals to tau is equals to minus K into L/2 theta into the distance is L. So from here what we get is K L square theta upon 2, correct? So this is the restoring torque. Now as we know that the torque is given as I alpha. Torque is what? I into alpha. I is what? The moment of inertia. Now we are talking the moment of inertia about the hinge or the pivoted, that is at the center. So I will be ml square upon 12 into alpha. Now equating both the equations, what we get is minus KL square theta divided by 2 will be equals to ml square upon 12 into alpha. So 2 cancels 12 as 6 and L square got cancelled out. So from here what we get is our alpha comes out to be minus 6K upon M into theta. So from here what we see is alpha is directly proportional to minus theta. So what we can say that the oscillation is SHM, correct? So our omega comes out to be under root of 6K by M, correct? So the frequency will be what? Omega upon 2 pi. So it will be 1 upon 2 pi under root of 6K by M, correct? Now checking out the options, what we get is our option number 3 is the correct option, 1 upon 2 pi under root of 6K by M. Okay, thank you.
हेलो स्टूडेंट्स, इस क्वेश्चन में हमें दिया गया है टू बॉडीज m and n of equal masses are suspended from two separate massless springs of spring constant K1 and K2 respectively. If two bodies oscillate vertically such that their maximum velocities are equal, तो ratio of the amplitude of vibration of m and n is, ठीक है? देखो आपको बोला गया है कि मैक्सिमम वेलोसिटी ऑफ m, मैक्सिमम स्पीड ऑफ m मान लेते, वेलोसिटीज ऑफ m वो क्या है? बराबर है मैक्सिमम वेलोसिटी ऑफ n के, ठीक है? वेलोसिटी ऑफ n, करेक्ट? यानी कि मैक्सिमम वेलोसिटी क्या होती है, a1 ओमेगा 1, ठीक है, ये बराबर किसके होगा, a2 ओमेगा 2 के। आपको बताना क्या है, आपको बताना है एम्पलीट्यूड बताना वाइब्रेशन, यानी कि a1 और a2 का रेशियो बताना है। तो a1 बाई a2 आपको फाइंड करना है, और वो होगा क्या, वो होगा ओमेगा 2 अपॉन ओमेगा 1। अब देखो ओमेगा जो होता है स्प्रिंग मास सिस्टम का, वो क्या होता है, देखो पहले तो होता है 2 पाई अपॉन टी होता है, ठीक है, और टाइम पीरियड जो होता है स्प्रिंग मास सिस्टम का वो होता है t इज इक्वल टू 2 पाई अंडर रूट m अपॉन k, ठीक है। तो ओमेगा की वैल्यू लिखूंगा यहाँ से 2 पाई अपॉन टी होता है, टी हो जाएगा 2 पाई और अंडर रूट m अपॉन के, अंडर रूट के, ठीक है, यानी कि ओमेगा की वैल्यू होगी रूट के बाई एम, ठीक है। अब देखो पहला अगर इसका ओमेगा मैं मानू, ओमेगा 2, देखो ओमेगा वाली जो ओमेगा 2 वाली जो स्प्रिंग है उसका कांस्टेंट है k2 और ओमेगा 1 वाली का स्प्रिंग कांस्टेंट है k1, तो ये क्या हो जाएगा अंडर रूट k2 बाय m डिवाइडेड बाय अंडर रूट k1 बाय m, क्योंकि मास तो सेम है, करेक्ट। अब देखो m से m क्या हो जाएगा, कैंसिल आउट हो जाएगा, तो a1 बाई a2 जो आ गया, एम्पलीट्यूड का रेशियो जो आ गया वो आ गया अंडर रूट k2 बाई k1, ठीक है। तो अंडर रूट k2 बाई k1 कौन सा होगा आपका, ऑप्शन नंबर डी। सो डी इज द करेक्ट आंसर, ये k2 बाई k1 आ जाएगा।
Hello students, today our question is a spring block system is resting on frictionless floor as shown in the figure. The spring constant is 2 Newton per meter and the mass of block is 2 kg. Ignore the mass of spring. Initially the spring is unstressed condition. Another block of one mass moving with speed 2 meter per second collides elasticity with the first block. The collision is such that the 2 kg block doesn't hit the wall, and the distance in meter between the two blocks when the spring returns to its unstressed position for the first time after collision is, so this is after collision here. So after collision is, so we have 1 kg mass here and 2 kg 2 meter per second, and this is the spring constant here, so spring here. So the solution of this question is, firstly we can draw the diagram for it. This is 1 kg and this is 2 meter just before collision here. So this is for just before collision, and this is the diagram just before collision here. This is with zero velocity here, and just after collision, this is 1 kg, 2 kg, 2 kg here, and this is 2 by 3 meter per second, 4 by 3 meter per second, and this is in this direction and this is in this direction, and we have the spring here, and just after collision here, just after collision here, and from this we can write here time period for this is equals to 2 pi, and this is under root mk, m divided by k, where m is mass here and k is spring constant. So this is equals to 2 pi second here. Block returns to its original position here. So this is pi by 2. So this is pi by pi second here. This is 3 divided by 2 here. So from this we get d is the distance here. It is equals to 2 by 3, and this is pi here, and this will equals to 2 by 3 and pi value is 3.14. So we get this is 0.33 meter here. So from this we get D is 2 meter here. So this is the distance after the collision here. So this is our answer. Thank you.
Hello everyone. Let us try to solve the given problem. So the given problem states a mass m is undergoing SHM in the vertical direction about the mean position y0. So this is y0 mean position and this mass is doing SHM with the amplitude A and the angular frequency omega. The amplitude is simply capital A and its angular frequency is omega. At a distance y from the mean position, the mass detached from the spring. So at some distance y, this mass is detached from the spring. Assume that the spring contracts and doesn't obstruct the motion of mass m. So when the mass is detached, we can assume that the spring doesn't obstruct and the mass continue to move upward, right? Find the distance y. We have to find the distance y measured from the mean position such that the height attained by the block is maximum, right? So let us now try to see what is happening. So you can see here the spring gets detached from this mass when it is at some position y. Now at that position the block must be moving upward with some velocity, let us say v. So now first we need to find v, and then we can see that the total height attained by this block, since it has some velocity, so it will continue to move upward, right? With a acceleration g acting downward on this block, it will continue to move upward until its velocity is 0 at some point, right? So now let's take this as v dash, so there is no confusion. So first we need to find out h, but before h, let's say what is the velocity of this body when it is at height y. So equation of velocity is simply omega times under root a amplitude square minus y square units per seconds, right? So this is the speed. Now what will be the height attained by this mass? So you can see that this has velocity v, so it will attain a total height due to this g. Total height attained by the block will be simply equals to y. So we have to find it this height from the mean position, y plus v square divided by 2g. Why v square divided by 2g? Because this final speed will be 0 and you can apply the equation of motion. So you can simply apply the equation of motion, v dash square is equals to v square minus 2g. Let's say this height is x, right? So you can find the x from here. So v dash is 0, so you can find the x, v square divided by 2g. So this height from here to here due to the velocity is v square upon 2g. So we will add. Now we have to find what is the value of y for which the height attained by the block is maximum, right? Now we have to, for maximum or minimum, we have to differentiate this equation. Let us differentiate dh divided by dy. So first we will put, so we will write like this, so dy. Now let's take this, so let us now put the value of v square. So v square is simply omega square a square minus y square divided by. So you can see I have differentiated this function. Differentiation of y will be simply 1 with respect to y, and this is omega square by 2g is constant, so this will come out. So this a square is constant, so its differentiation will be 0, and minus differentiation of y square will be 2y, right? And we have a minus sign here, so I have put a minus sign here. So this will cancel out, right? So what we are going to get for maximum minima, this has to be equals to 0. So we are going to get 1 minus omega square y divided by g, and from here, so from here we can find out the value of y, and it is simply y equals g divided by omega square. So this will be the final answer. I hope you understood the explanation. Thank you.
Hello everyone. So our question is, a mass m is attached to a spring oscillation with a period of 2 seconds. If the mass is increased by 2 kg, the period is increased by 1 second. Find the initial mass m assuming that the Hooke's law is obeyed. Okay, now we have been given that the time period of oscillation has 2 seconds, and when the mass is increased by 2 kg, then the time period also increases by 1 second. We have to find the initial mass m. Okay, now let's suppose that the initial mass is equals to m. So the time period will be given as t is equals to 2 pi under root of m by k. Correct. Now initial time period was 2 seconds, so this will be 2 is equals to 2 pi under root of m by k, or what we can write it out as 4 will be equals to 4 pi square into m by k. Let us suppose this is your equation number 1. Now when the mass is increased by 2 kg, time period also increases by 1 second. So the new time period will be equals to 2 plus 1, that is 3. That will be equals to 2 pi under root of m plus 2 divided by k. So this can be written as 9 is equals to 4 pi square into m plus 2 upon k. Let us suppose this is your equation number 2. Now let us divide equation number 1 with 2. So we will get 4 upon 9 will be equals to m upon m plus 2. So on solving this, we will get our m coming out as 8 upon 5 or 1.6 kg.